Hello and welcome to this presentation which serves as an introduction to data collection for Unit 1. I will also be talking about data collection in Unit 3, but data collection in Unit 3 has a particular focus in terms of collecting information to support your software requirement specification. So this is specifically for Unit 1, which is more it's sort of overlapping with data analytics. So, students can explain and implement key concepts in data collection. Now, I know that's pretty vague, but I am going to unpack what those key concepts are. You're going to know the difference between a theory and a hypothesis, and you should be able to define both of those. You should understand what quantitative data is and qualitative data, and again, the difference between those. Between data and information, I have to say there is a textbook definition, which is what I'll be presenting today, but the line between those two is not quite as bright as I would like. Primary and secondary sources, they're a pretty clear distinction, and you've probably learnt about that in other subjects too. So that's what we're going to be looking at today. So what are we going to start with? Well, let's start with the scientific method, because this is what we're drawing on when we're collecting data. So we observe a phenomena. So I notice that that side of the house tends to be hotter in the morning and that side behind me tends to be hotter in the evening. So that's a phenomena. And I develop a theory to explain this. A theory is an explanation of how the world works. So my theory is that the sound of birds singing, it makes that side of the house hotter because they sing more in the morning. And I formulate a specific hypothesis from that. And so my hypothesis is, and this is something that is testable, and I'm coming to this, is that when the bird song is louder, the measurable temperature will be higher. And I collect data to test this hypothesis. And then I analyse the results. Then I refine my theory based on the findings. So I might, in fact, go on and say, okay, it's only native birds where there's the correlation, it's not all birds, or I might reject it completely. So, the difference between a theory and a hypothesis. This is where you jump on and tell me what the difference is. So, let's unpack what a theory is. I love in this image here that the projector is missing the whiteboard. I love how authentic that is. So a theory is a well-substantiated explanation of an aspect of the natural world or social world. So my theory about birdsong heating up my house probably actually doesn't pass muster in terms of being a theory in this sense, because it's nonsense. Like, it's not well-substantiated. It's more like a belief than a theory. And it's based on a body of evidence that has been repeatedly tested and confirmed. So a theory is different to what I would call a harebrained idea, or more benignly just a belief that, birdsong warms up my house. I'm perfectly entitled to hold that belief, but it probably doesn't rise to the level of being a theory. I have noticed in recent times that there's this idea that all theories are equal. And I guess this is what I'm presenting to you is pushing back on that and saying, no, theories meet this criteria. Just, that the idea that birdsong warms up your house as opposed to sunshine or radiation from the sun, that these are not equal in the eyes of science. You can hold both beliefs, but they're not equal in terms of the scientific process. So a hypothesis is specific and testable about the relationship between two and more variables. So I'm testing time of day and temperature in my house. And if I were to test I think I'm going to move over and test the idea that there's more sunshine, because that's got a greater body of evidence behind it. So I'd probably be measuring the intensity of the sunshine and how warm my house is. Typically derived from a theory, and it serves as a basis for my investigation or my data collection. And it must be testable. It must be falsifiable. So you'll be able to say, oh, well, this disproves my theory, or my hypothesis. I'm rejecting the hypothesis. It turns out there just wasn't data for it. And that's one of the big things about just beliefs. Beliefs that can't be changed are fine, but they're not a hypothesis, they're a belief. And they're specific and clearly defined so that we can actually say, yeah, that's what turned out, this is what's supported, this is what's unsupported. So when we collect data, we do it to test a hypothesis. We're not just collecting it for the hell of it. So let's do a quick test. Theory or hypothesis? If I increase the amount of fertiliser given to tomato plants, they'll grow taller than plants given less fertiliser. Well, that's a hypothesis. It's testable. We're saying if this happens, we will get that measurable result. Many illnesses are caused by microorganisms that invade the body. It's too broad. It's too broad to be a hypothesis, but it is a theory of causation, and most theories are theories of causation. This means that. So that's a theory. Students who study for 30 minutes each day will achieve higher test scores than students who study for only 10 minutes a day. That's a hypothesis. It's testable. It's specific. The movement of the Earth's lithospheric plates and accounts for earthquakes, volcanic activity, blah, blah, blah. Well, that's a theory. That's saying the movement of this thing causes this thing. You could have a hypothesis coming from that, but that in itself is not a hypothesis. If students use dark mode on their computer screen while programming, they'll make fewer coding errors than students using light mode. Well, that's a hypothesis. It's testable. It's not as specific as I'd like, but it's testable. All living organisms are composed of one or more cells, and the cells are the basic unit of life. I actually think that's more like a theory than a hypothesis. It's basically saying this is how the world works. And then you might go through and say, well, humans are composed of more than one cell, and we go and test that. And playing video games for more than 2 hours per day will result in decreased physical fitness levels for all teenagers, compared to those who play for less than 1 hour a day. Well, that's a hypothesis. That's testable. So now we understand a theory and a hypothesis. Let's move on to what we mean by qualitative data. I always stumble a bit on that. There's too much going on in the middle of the word. That is non-numerical information that describes the qualities or characteristics, and we're typically collecting it through observations, interviews, or descriptive methods. So when you sit down and say, well, what's the best thing that happened to you today? Or, how have you been? You're going to get a qualitative response. Somebody's unlikely to say, 7.2. They might say that, but that wouldn't be qualitative. So lots of the way that humans interact is qualitative, and there's real value to collecting qualitative data. Sometimes people treat that, well, that's not real data, that's anecdote. You can analyse it, you can collect it, it's got a place in this system. There are two types. There is nominal data, which is categorical and has no inherent order. So, for instance, gender. The order isn't, man, woman, non-binary, and so forth. They're all sitting there next to each other. It's not blue eyes, brown eyes, green eyes. There's no hierarchy there. And there is ordinal data, such as your education level. Are you, highly educated? Are you not highly educated? Are you highly satisfied? You often see these with these things called Likert scales, Likert. I'm not sure if I'm pronouncing that right. So that fits into qualitative data. Yep, the quality of something. Now this is quantitative data. Quant as in quantity. It should be expressible as numbers. It should be objective and measurable. You and I should both get the same temperature readings. We might stand in there and say, is it quite hot or really hot? And we can disagree about that, but we should all be able to say it's 21.3 degrees. It can be statistically analysed. It allows for mathematical operations. You have discrete data, which is whole numbers and countable values, such as the number of students or the items sold, and you have continuous data, which can have fractional values. This is a bit of an arbitrary distinction, but one's likely to be an integer and the other's likely to be a float. So let's test what we know. Qualitative data is always collected, so qualitative means the quality of it is always collected through written surveys and cannot be gathered through observations or audio recordings. Well, that's just false. Quantitative data, so quant is numbers, can be analysed using statistical methods. Yep. Mean, standard deviation. Yep. Correlation coefficients. Yep. To identify patterns and relationships. Yep, I agree with all of that. A researcher conducting interviews with 10 small business owners about their experiences during COVID-19 pandemic would typically be collecting qualitative data. Yeah, I think so, because you're not going to get a real depth of understanding of what it was like from just quantitative quantitative data. The numbers wouldn't tell the story. There'd be too much variation in what their experiences were like. Too many answers that we just couldn't expect. So we would want to have qualitative data to get the full depth of their experience. So, quantitative data is always numerical. So quant, numbers, is always numerical in nature and can only be collected through instruments such as thermostat scales or digital sensors. No, I don't think that's true. I mean, yes, it would be numerical, but it doesn't mean that it has to be collected by an instrument. That's just checking the answer sheet there. Qualitative data, so the quality, often involves coding and categorizing responses to identify themes and patterns rather than calculating numerical statistics. Yeah, absolutely. If we're talking about that previous question about business owners' experience during the pandemic, then yeah, you would say people experienced high levels of distress, like many, most participants indicated that they experienced high levels of distress. A hypothesis stating students who attend tutoring sessions will score 15% higher on mathematical examinations than those who do not is best tested using qualitative data. No, you'd want quantitative for that. Okay, so let's talk about data and information. Sorry, I just kicked the green screen behind me. I have to say that I don't think this is very well distinguished in everyday language, even in computing, but, the serious people will tell you that data and information are different. So data refers to the raw, unprocessed facts and figures that have been collected, but not yet organised or analysed. So if I'm writing down the temperature in my laundry, which is just the next room, as the day goes on, yes, I'm collecting it chronologically, but it's still regarded as data at this point. It hasn't been analysed. It's just, it's got some structure, but no level of organisation beyond that. And it exists as individual values and measurements without context or meaning. And again, I'd have the times next to it, but we're talking about a bit more context than that. And it can take many forms, numbers, text, images, audio, sensor readings. Information is data that has been processed, organised, structured or presented in a meaningful context. So we're taking it and we're saying, okay, we now have, we can say that the temperature went up during the middle of the day, that the temperature increased sharply between 10 and midday. We're actually sort of describing the data and ascribing meaning to it, and now it becomes information. When it's given meaning, there we go, and it can support decision making and understanding. The transformation from data to information involves several processes. This isn't an absolutely hard and fast, you have to go through and tick off all four, but this is generally what's involved. You give some context about the circumstances regarding the data. It's organised in a meaningful way. It's analysed for patterns and relationships, and it serves a particular purpose in terms of what we're using that data for. So, what is the difference between primary and secondary source of data? This is the next thing we're going to talk about, and you might have heard about this in other subjects. History particularly uses it, but it's a fairly broad concept, a broadly used concept. So, a primary source of information is original, first-hand sources of data that have not been interpreted or analysed or filtered by others. So, it is the original data. Again, there's a kind of misconception that the only good data is primary data, or is primary source of data. Absolutely, they're valuable. I would worry if you never could trace your ideas back to primary data. There's nothing, it's not the only form of valid data. They represent the direct collection or observation of data from its point of origin, such as sensor readings from the IoT device, that's Internet of Things by the way, database records created at the time that something happened, survey responses collected directly from participants, server logs. All of these things, original data sets from your scientific experiment. All of these are primary sources of information. Whereas a secondary source of information is derived from the primary source through analysis, interpretation, summarisation or reorganisation. So it might be that you're putting, your Beatles records into categories to say, well, this is no longer just a list of Beatles records, now this is their early period and this is their psychedelic period and this is their return to their roots period here. Once you're organising it, it actually becomes secondary data. and it's been processed or evaluated, even graphing something, because you're deciding the range and the colours and what the axes are and so forth. When you're telling a story with it, you're actually transforming it from primary data to secondary data, and that's okay. It still has meaning. In fact, sometimes you'll get more meaning out of it. So website traffic, academic papers discussing research findings, that would be their research findings, not other people's research findings. It would be either. Beg your pardon, I was getting myself confused there. Data visualizations, news articles, and reviews. Textbooks, the wiki that I've got in the background here. So, what do we know? A database record contained when a customer makes an online purchase is a primary source of data. Yeah, of course it is. Yep, that's as raw as it gets. A news article reporting on the ABS census findings is an example of the primary source because it contains factual information. No, secondary source, they're not the source of the information. Some of that's been condensed and summarised. It's in fact a million miles away from being a primary source. Server logs that automatically record every user click on a website are secondary sources because they've been processed by the web server. No, they're primary sources. They're the they clicked on this pixel at this time. It doesn't get any more specific than that. There's been no interpretation and so forth. It's just been recorded. The recording doesn't change it. A data visualisation chart created by analysing raw survey responses from 500 Australian students would be classified as secondary source. So it's a data visualisation, so it's automatically, pretty much automatically a secondary source because you're imposing some meaning on that or you're drawing out some meaning. Raw temperature settings. Well, I can tell you pretty much straight away that that's primary. So we've done those. And actually, you know what? It would appear that we're at the end of the presentation. So that went quicker than I thought it would. I hope that's been useful to you, and I'll see you in another presentation.